Bueno, bienvenidos, bienvenidas. Hi everyone, welcome. Bueno, es un placer para mí, para el Planetario y un honor estar acá hoy en este gran evento de Nerdearla. Voy a presentar a Jolo, que es uno de los organizadores, para quien no lo conoce, quien está viniendo de parte, digamos, del Planetario. Estamos muy contentos, espero que disfruten de este evento que va a tener grandes personalidades y charlas súper interesantes. Yo los dejo, no saco más tiempo. Gracias, Jolo.
Gracias a vos, gracias a toda la gente del Planetario, gracias Diego por la clase magistral. Yo siempre a Minera le mostraba Betelgeuse, ahora le voy a mostrar, no sé, la pierna del Ivo porque me encantó esa descripción. Quiero hacerlo súper corto, tenemos 3 invitados increíbles, tenemos 3 entrevistadores también increíbles. Muchas gracias a toda la gente que está acá. Confieso que vengo a hablar en el Conex, a hablar con un montón de gente. Siempre quise pararme acá. O sea, yo hice un montón de cursos con Diego. Es increíble esto. Así que, en realidad, lo que valía era esto. Bueno, tenemos un solo slide súper corto, como para contar para la gente que no estuvo en el Conex hoy, si se puede poner en pantalla. ¿Qué es Nerdearla? No sé, ¿quiénes fueron al Conex hoy? A ver. ¿Quiénes estuvieron? Bien. Estoy pasando lista. Genial. Bueno, la gente que no vino, sepa que Nerdearla es un evento de tecnología bastante grande en Latinoamérica. Hoy ya vinieron más de 2.000 personas. Esperamos mucha más gente mañana y pasado. El sábado, sobre todo, es el día como más nerd, así lo llamamos. Hay charlas de astronomía, de ciencia, de física, de química, de un montón de cosas, así que están todos más que invitados. El evento es gratuito, ahí está. El evento más grande de Latinoamérica, es la 10ª edición, lo venimos haciendo en 2014. 100% gratis, se pueden registrar en la página web. Estamos hasta el sábado 30 en el Conex. Nos pueden seguir en las redes sociales, el hashtag es Nerdearla. De nuevo, invitaciones a todos ustedes a que se registren y vengan mañana y pasado. De nuevo, no voy a decir mucho más, tenemos la primera charla, la primera entrevista de Pia y Megan. Ahora igual la voy a presentar a Gala, no sé por dónde, ya llamé María, ahí está, Gala. Los dejo con Gala, que va a ser la host del resto de la tarde. Gracias.
Hola, ¿cómo andan? ¿Todo bien? Bienvenidos. Qué loco estar acá en el Planetario, me flashea mucho. Yo soy Gala, soy periodista de tecnología. Gracias por nerdearla. No sé por qué dicen tan al pasar que son 10 años de esta conferencia de tecnología, pero yo voy a pedir un aplauso por eso. Sí. Porque la verdad es un flash, es una conferencia para nerds todoterreno y esta noche en el Planetario, que es, no sé, a mí se me pone la piel de gallina con la presentación, así, con todas las estrellas y también con las personas que van a estar ahora acompañándoles en el escenario. Les puedo contar. Voy a empezar por el final para presentar a quienes empiezan la jornada. Van a ser una serie de entrevistas, pero me gusta más decirle charlas, ¿no? Conversaciones. Si tienen alguna pregunta, quizás en algún momento puedan hacerla. Está Miguel San Martín acá, es un argentino que trabaja en la NASA, no sé si lo conocen. Hola, ¿cómo estás? Vamos a tener la oportunidad de hablar con él sobre todas las misiones que se están haciendo en Marte. El encargado es Guido de Caso, es programador, pero súper fanático de la astronomía y también es un súper nerdo. Va a estar Douglas Crockford hablando de un lenguaje de programación que quizás conocen, que se llama JavaScript. También fue creador de Jason, ¿no? De este personaje tan mítico del cine de terror. No, eso no. Pero sí es un formato, ¿no? Que articula la Internet como la conocemos hoy en día. Juan Cruz Nores, que está ahí. Después se va a hacer snowboard a las montañas, pero hoy está con nosotros para acompañarnos. Y bueno, ahora sí. Pia Torres es ingeniera electrónica de la Facultad de Ciencias Exactas, trabaja en Woman in Engineer y Roboteam, y va a estar conversando con Megan Smith, que vino de Estados Unidos. Ella es una mujer increíble con una vasta experiencia en tecnología. Trabajó 10 años en Google, fue vicepresidenta de la empresa y luego fue directora de tecnología del gobierno de Obama. Fue la tercera en ocupar ese puesto y nada, las dejo con ellas porque acá las palabras sobran. Gracias.
Hello.
Hello, hello. Thank you.
Incredible in
This
here.
is very good. It's cool to be here. Okay. Well, I think she was also sharing a little bit about your bio, but I have a very cool bio I would like to share with the audience. So, just to let you know, for many people, as myself, that I'm a declared fan of you. Megan, she's a visionary tech leader, she's an entrepreneur, and also a huge advocate for diversity and inclusion in technology. We know that she was working in the government, but she also worked in the cooperative. She has done also many things and also create new business. And also, I think you have this passion for technology and how people is involved in technology. So my first question for you, let's do it as a conversation, is what can I tell you about your background and experience, and what are the biggest, not challenges, maybe which are the biggest goals you achieved during your life?
Thanks. It's amazing to be here in the planetarium. I think that one of the things I found, I had the chance to, as a very young person, and we talked about how do we bring more young people into STEM. Our high school, it required science fair. So a lot of times programs for project or hands-on learning for kids are an option. It's a club or a separate thing. But like you are doing with the robo teams, having kids actually get to do something. For me, President Carter was the president in the US, and we had serious energy crisis. And so he was putting solar panels on the White House. And so I ended up doing most of my projects as a child on green energy. So solar and wind and these things. And for me, we didn't have the internet, but we went to the downtown library to get more books. And I found that I could look from that content and start to realize that I could invent things, I could make new designs or think of how to use these principles in that way. And I think that's a really, practice makes permanent, is what my swimming coach used to say. And I think the more we can bring young people into all the professions, just like we learn to write, we learn to write essays, we can also learn to invent, discover, design, and be part of these worlds as well. So that was, I think that allowed me to come into this path. And so I've done lots of different things, from working on smartphones with incredible teams to working at Google, and then having the honor to go to the White House to work for the president and to bring more technology, data, and innovation into the practice of government, which is quite urgent for all of our governments. They're getting kind of rusty. And government is only whoever shows up. And so if none of the tech and innovation people are coming regularly into government, and none of the people there are pulling us in, we won't be as innovative with our government, even though they have the most money. And we could really solve a lot of things with them.
And you shared with me this, but I think it will be a very nice story to share with the audience. How was that call, the first call from the White House, asking you to come and change maybe your line of work from cooperative level to government? Can you share a little about?
Yeah, and I think for me, I was really surprised, because I thought, why would I go in the government? And I think for a lot of us, we don't, unless we are already working in government. Of course, every government has scientists. Of course, Miguel and the NASA team for US and the global teams there, energy, IT, defense, etc., transportation. But the technical people are not in the senior leadership of the countries typically, maybe a science advisor, but often the kind of disruptive techies, data science, hackathons, this kind of method isn't happening. But I would say even yesterday, the US announced a lot of changes to our foster care rules and billions of dollars, and we can route that from a foster care hackathon we did in 2015 to begin to think about and prototype in new ways on behalf of foster care. In this case, allowing for money that we have for children to go to grandma or other family members if they're taking care of children, as an example. So, I think that we don't ever say there's government and there's lawyers but we say there's government and tech, like tech sector, as if commercial tech is the only tech, when really we need civic tech, philanthropy tech, nonprofit, and commercial. All of these things could have technology with them to make things dramatically improved in terms of the capabilities that we can do. We're connected at the speed of light. And also, importantly, to protect ourselves from the downsides of technology. We see lots of scary things right now with the way that artificial intelligence is being designed. And part of that is because most of us, maybe the artificial is tech, but the intelligence is everyone. So, why are people in jail tonight because of face recognition mistakes? But that's true already. So AI and algorithms is already causing problems. And we really have to get into that. And the way to do it is bring more people into the conversation and require the solutions for everybody to be inclusive before we ship the products.
Okay, you mentioned innovation. You mentioned also some inventions. So maybe you can share with us your part of General Magic. You named that as a crazy company. Can you tell the people here more about that? Maybe invention, little invention.
Yeah, we, sometimes when you're young, you get a chance to work on extraordinary teams, and I had that chance. Some of the team who had made the Macintosh with Steve Jobs, Joanna Hoffman, who's the product manager. You see her in the movies. Kate Winslet won the Golden Globe for playing her. Susan Kerr, who did all the graphics that we look at today, all the colors and so many things that are, on our icons. That's her. Andy Hertzfeld, Bill Atkinson, this amazing team that came up with this with Steve, spun out to work on the beginning of smartphones. And we were young, and we joined them. And so I'm a mechanical engineer, so I was working on touchscreens and LCDs and cameras. And I remember Andy said, Megan, make sure the camera prototype is there, because people are going to take pictures and send them all over the world. And this was in 1992.
It was crazy at that time.
So we knew it could happen. We were too early. And the film is actually an interesting film because it's about not making what you hope or passionately believe in. And so part of technology, of course, for all of us is having a passion or a vision for what can be. It's a team sport, and coming into trying to do that together. And then learning through prototyping and shipping, is it going to work, and iterating and the changes that we have to do. And so it was an amazing opportunity and honor to get to work on that team.
You mentioned there are some people who are working together. It's amazing people as you are. For the people here, please don't miss the General Magic movie. It's really nice, and it's telling about her story, so I recommended that. You mentioned something very interesting to me because it's also my way of living and also working. You mentioned how important it is to build a diverse team. I know you are a very great advocate about diversity. And what is diversity for you? What is very important for innovation?
Yeah, I think it's interesting because the studies that we have about diverse teams tell us we always have more creativity, more revenue, more innovation, more productivity if we have lots of different kinds of people working together, both men and women, LGBTQ, different races and backgrounds and locations, also many different disciplines, in different ages. The more we have that friction of different styles, actually the more inventive we are. So the more we can think about how to include each other and think about belonging, as well as composition, proportion of people, but how are we making this a belonging place? And I think, one of the examples of diversity that I was thinking when we came to the planetarium is we are in the middle of this idea of automation and artificial intelligence, but actually the greatest capacity is still human intelligence. And one of the groups that I would share, and I'll say a little bit tomorrow in my talk, about a group that's called the Hokulea. And if you saw the movie from Disney about Moana, maybe you have children, so you saw it 300 times. That's real. And I've been in a planetarium with Nainoa and Lehua, who are both master navigators, explaining the stars and how they navigate. And imagine just like the group of us right here, if we were on a sailing canoe about the shape of this area, and we're in the middle of the Pacific Ocean. Does anyone here know where to go? Because they do. They really do. And they can navigate anywhere in the whole planet. Yeah, no, I did the acquisition of Google Maps when I was, so there's a book called Never Lost Again. But they don't have any Google Maps. They only have the stars and the feeling of the currents. And they can go, and they sailed around the world in a Polynesian voyaging canoe. And they've just begun a second voyage. They left from Alaska. They're in San Francisco now. They're circumnavigating the Pacific, which is actually a bigger journey. But to think about the most ancient of capabilities and what humans can do, and to be able to do that without technology, with kind of this is core indigenous genius technologies, is really profound. And so I think about how are we going to include more people? We have so many problems, and we have so many people, and somewhere on the planet, someone has an idea or a solution or a prototype or something for almost everything. Can we find them and lift them the way that we often lift certain groups, like the Silicon Valley people are getting more money, but how about everybody? And use the community of us to community organize innovation. Because technology, for me, the way I think about it is, in its best form, technology is about love. And it comes in really three ideas I have. One is curiosity, like look at what we just looked at, the sky and chlorophyll and trees and, how does this world work, right? Chemistry, poetry, art, curiosity. And then the second part I think about is ingenuity, engineering, the things that we can solve for each other. And when we're doing well for each other, and not extracting, but collaborating and sustainable. And the third one is teamwork. And how do we include everyone on the team and have technology not be something that we threaten, like math is hard. It's not hard. I guess it is hard sometimes, but it's not hard in a way that writing a great essay is hard. Everyone could do math if we teach it right. So, I don't know, that's how I sort of think about this.
Okay, and I totally agree on that, and I think the big, or maybe the fifth revolution is about people. People empower people, sharing ideas and building this technology to be serving communities and humanity. And when I see the future, we are in the middle of many technology advancements every day. You mentioned AI. There are many things that are growing, these disruptive technologies. There is some specific technology that you are interested in, and how do you envision the application of that technology in the future world?
I don't always think about the technology, I think about the people. And today I had the honor to go to Plaza de Mayo at 3:30. And it was amazing because the Madres were there. The Madres de la Plaza de Mayo, and it made me cry. They are incredible. And I was thinking, like, how can technology help them with the suffering that they've faced and the possibility of, we have Nick here from the open source, open innovation. We were talking about humanity has made this shift to a more open way, probably around the turn of the millennia. We had, just before that, Truth and Reconciliation, South Africa. We have open source. We have Wikipedia. We have these ideas, open courseware. We're sharing. How can we think about, how can we make that kind of future that they suffered not happen again? And isn't that just as much a priority as self-driving cars? Maybe more. And so I'm interested in where we can be as technical people, scientific people, where we are more rare and we can respect the extraordinary knowledge of the other colleagues who have worked in those areas for so long, and maybe we can listen to them. It's something I saw in the White House. If we watched what people were doing around justice, or like we created Police Data Initiative or data-driven justice. We can bring tech and data, open data for policing, because there are a lot of challenges in the United States and around the world with police issues, good police and then police acting in bad ways. Can we see that better? And can we surveil that in a way that's not going to hurt people, but going to help people there? So those are the kinds of things that I think we have the opportunity to use our technology for, and at the same time also push back on algorithmic injustice, like those who are in jail tonight, and try to solve for that and include people. So that's my focus right now. So the technology is really less about it and what we might do together as we discover both the curiosity of it, the engineering of it, and the teamwork of it, and what it could be.
Thank you so much. It makes me feel chilly because I agree with that, and I think how the humankind is an amazing group of people that we need to go to the future, and we need to start thinking how we're going to use our tools better, right? And I know you're passionate about finding solutions, because every time we are having these conversations, you're connecting people and trying to find solutions. And I think that is why you were also inspired to be an entrepreneur, because you would like to find solutions, to see the problems and to find the proper solutions to that. Can you tell us a little bit about your entrepreneurial journey and what are you doing right now?
Yeah, so I think one of the things that I'm friends with Reid Hoffman, who created LinkedIn, and he's always doing things, and he said, whenever you have some founder or a couple of founders, you need smart generalists. And that's people who join them because they see the idea, and together, very much how Ariel and everybody came together to make Nerdearla, right? It's a flash mob, come together, make the thing together. That's how we do, companies. There's a business model for companies because the venture capitalists can give some funding, and then we kind of like a pizza, we have a slice for them and a slice for everybody else, and we can keep growing if we're successful. And there's models in that, the commercial side, for lawyers and all kinds of marketing, all different people to play a role. It's harder in government and nonprofit and philanthropy because the ways that the disruptors can do their thing is not as obvious. And so we have to figure out how to do innovative things in those areas. So I like to stay in the place where tech people are more rare, not because I don't love my colleagues in tech, but I got a chance to do that so much that now I told the MIT students, I did a commencement address, I told them, go where there's many of us and advance the field, and go where you're a bit rare and listen and see what people are doing. And maybe you can help and you can learn a lot, and so I'm staying in that area a little bit more these days. And one of the things that I really love to focus on is something I call scout and scale. There's so many people already fixing things, but they don't have connections or acceleration or other ways, like venture catalyzing things. And so the more we, instead of say, oh, what do we do about education? What do we do about this? If we look up and say, oh, wow, you're doing that about it, and you're doing that, and we help the people, then we don't have to do the work. They're doing the work. We help them, and we can have a massive surface area of much more solution making. So it's almost like community organizing the innovation, something I love to work on.
It's amazing. And we have here in Argentina a very nice community of women entrepreneurs and also women entrepreneurs that are coming from the technical field. Do you recall any event when you were maybe have discrimination because you were a woman, maybe in your career as an engineer or as an entrepreneur?
I think most people, everybody has the idea of, I don't belong a little bit. Boys, girls, everybody, you're afraid sometimes. Sometimes we have these ideas, math is hard and these things. I think everybody has that, but I think there's especially a lot of microaggressions that happen to some people because maybe we didn't see as many women on TV being engineers as men, or all these things. Even in my own life, I haven't faced a lot of direct discrimination, but one that's kind of interesting I was thinking is my grandfather was lucky to come to Uruguay, and he was working at U.S. Steel, so he was just north of us in Nueva Palmera, working on shipping docks here in the 50s. And many people in my family are engineers, and he loves engineering. civil engineer, industrial engineer, built highways in Indiana, and so many. He'd be working with us. He'd come to Nerdearla if he was alive. He was born in 1901. But because he was born in 1901, when I said to my mom that I was going to go to engineering school, and she told him, he's like, why would she want to do that?
Why not?
And because he couldn't imagine his granddaughter, he can see his grandson, but not his granddaughter is going to be an engineer. But then the good news is once I graduated, he's like, my granddaughter is an engineer. So, people can come and learn, but it's all around us, this micro-discrimination. And the people who face the most discrimination are the women of color. In the world, they're the lowest paid, the least included. They don't get venture capital. Already, women don't get much, but amongst people of color are getting a lot less. And so we have a lot of work to do because there's so many solutions and inventions and discoveries and things that we're missing out on that they have, and they aren't able to scale them like others are able to get the resources and the visibility. Treasure, money, and network. Treasure, visibility, and network. So we want that for everybody.
This is really inspiring, and I just want to end this conversation asking you for a piece of advice, not only for women, for any person who wants to be part of this technology innovation ecosystem. What do you suggest to them?
I think people should feel welcome and just find your passion. And if you don't have a passion, just start hanging out with people and helping, and you'll find something. I was lucky to take acoustics from Professor Bose, like Bose speakers, and he gave us some great advice that I'll pass on, which is, he said, find your passion, because you can work on many things, but there's a lot of people in the world. So unless you are totally required to do something, like it's by law or something, then you have to do that. But if you can shift, if you can find a way, find the thing you care about, because you're going to be orders of magnitude stronger at doing that. And I think it's really great advice. He also said, if people are not kind, because I think this is a world where there's a lot of knowledge, focus on knowledge, but kindness is probably more important than knowledge. And so if people are not kind and collaborative, find a different team. Give them feedback, try to help them, but if they can't get there, shift teams and maybe they'll come around. But these are really important things, because then you can realize your potential, and we really need you in the world. We need everybody on the things they care about. So it's an honor to be in Argentina. I am so happy to meet everybody and to have more colleagues from this part of the world, and to see Orion upside down for me. It was great. And the Southern Cross.
Okay, it was a pleasure to meet you. It was a pleasure to have you here. In the name of Nerdearla and all the people here, we appreciate your kind words, your knowledge, your career path. You have done a lot of innovation, and you are inspiring us to try to do our best as well. Thank you very much.
Thanks, Pia. Thanks for your leadership.
Thank you.
Muchas gracias. Increíble. Sí, pueden dejarlo acá. Perfecto. Un gran aplauso. Chicas, es muy inspirador realmente todo esto. Me quedé con esa idea de que la tecnología, en definitiva, es amor. Y yo siempre pensé que lo que a mí me pasaba con la tecnología era amor, y está bueno de repente estar acá con estas personas que nos acercan de una forma de que no es un amor platónico, inalcanzable, que es posible acercarnos y trabajar y dejar nuestra huella. Creo que un caso muy grande de eso es la huella que Argentina de repente deja en la NASA y en el espacio y en Marte. A continuación, ¿lo conocen a Guido de Caso? Porque él va a subir ahora al escenario. Él es programador, pero desde la pandemia que viene divulgando misiones espaciales de exploración. Fue invitado a la NASA, por eso, de hecho, a ver el despegue de la misión Artemis 1. ¿Cómo estás? ¿Todo bien? Mirá, ya te voy a pasar tu micrófono para que te vayas ubicando. Y Miguel de San Martín está de visita en Argentina, pero es su hogar, su casa. gusto tenerte acá. Y bueno, los voy a dejar charlar porque hay mucho que contar de las 4 misiones de Marte en las que ha participado. Gracias.
Bueno, Miguel, ¿cómo andás?
Bien, muy bien.
Muchas gracias por haber venido.
Oh, un placer. Para mí siempre es muy emocionante venir acá al Planetario, que venía desde chico a soñar y a ver este magnífico cielo que tanto me inspiró.
¿Y hablas de inspiración? ¿Qué es lo que te llevó, digamos, desde tus orígenes acá en Argentina a pensar en el espacio?
Bueno, es decir, en primer lugar yo nací con un interés por la ingeniería, digamos, de muy chiquito, ¿no es cierto?, que me gustaba todo lo que digamos, se movía, digamos, máquinas o electrónica, ¿no es cierto? Así que, y bueno, era la época digamos, del programa espacial cuando comenzaba con el proyecto Apolo, así que eso, obviamente, para un ingeniero, esa era la tecnología más alta que existía en ese momento, no competía con otras cosas que tenemos hoy, ¿no es cierto? Y eso me llevó la atención inmediatamente, ¿no es cierto? Y bueno, después el proyecto Viking fue para mí el último remate, digamos, donde cuando yo vi esa foto de la patita del Viking en la superficie de Marte, es lo que dijo, esto es el área donde yo quiero aplicar la ingeniería. Yo sabía que quería ser ingeniero, pero no sabía exactamente en qué, pero cuando yo vi eso, ya eso fue lo que a mí me hizo descendir, de emprender el norte y tratar de meterme en alguna misión y aterrizar en Marte.
El norte literal, ¿no? ¿Cómo fueron esos pasos para llegar a ese lugar?
Bueno, mi padre me aconsejó, Miguel, si vos quieres hacer ese tipo de cosas, te recomiendo que vayas a estudiar a Estados Unidos y te insertes en el mundo ese de digamos, las universidades de Estados Unidos y que le encuentres la vuelta de cómo hacer llenar tus sueños, fulfill your dreams. A veces me cuesta.
Lograrlos. Sí.
Lograrlos, tus sueños.
Cumplirlos, sí.
Y así que ese era el plan. El plan siempre era, el próximo paso se sabía, el segundo ya no es cierto? El primer paso era ingresar a una universidad de Estados Unidos, ¿no es cierto? Ese fue el primer paso. Y bueno, y ese fue el comienzo digamos, del viaje, ¿no?
Y vos hablas de estudiar ingeniería. ¿Cómo se vincula lo que viste en la facultad con después llevarlo efectivamente a la práctica en tus primeras misiones en donde fuiste participando?
Bueno, sí, mi primera misión no era Marte. Cuando yo llegué al JPL, estaba terminando Galileo, que era una misión a Júpiter, que me la perdí, es decir, llegué tarde. Pero aprendí mucho digamos, de esa misión, leyendo todos los memos que se escribían en aquella entonces, no había PowerPoint, y hablando con los ingenieros. Así que aproveché para digamos, un poco aprender cómo se hacían este tipo de cosas, ¿no? Y después esperar el momento que se me diera la oportunidad. Obviamente trabajé en pequeñas misiones, y después se dio Cassini, que fue la primera misión donde yo trabajé, que era una misión a Saturno. Yo tuve la oportunidad de ahí hacer un algoritmo de orientación de actitud, que vos sabés muy bien, que es la orientación del vehículo respecto a las estrellas, así que había una cierta poesía, digamos, en ese tema.
Navegar con las estrellas como los antiguos, ¿no?
Sí, como los antiguos y como mi padre hacía cuando construía caminos en la Patagonia, antes del GPS, ¿no? En los años 30. Se orientaban por las estrellas para navegar.
O sea, antiguos y no tan antiguos.
Y no tan antiguos, así que ese fue mi primer trabajo, digamos, donde yo hice un algoritmo, y para eso era uno de los objetivos, ¿no? Hacer algo que estuviera allá arriba. Y después esperar a una misión a Marte si venían, porque en ese momento el programa de Marte estaba bastante muerto, digamos, desde Viking, que no se hacía mucho.
Había habido una serie de decepciones, ¿no? Alrededor o quizás, no sé si decepción es la palabra, pero había muchas expectativas, quizás demasiadas, con respecto a esa misión Viking y lo que se iba a encontrar en Marte y lo que terminó sucediendo.
Exactamente, es decir, en Viking las expectativas eran no simplemente determinar si hubo vida en Marte, pero pensaban que iban a encontrar vida corriente, digamos, al punto que los instrumentos científicos estaban diseñados para detectar metabolismos o fotosíntesis digamos, de organismos vivos, ¿no es cierto? Y no solamente no encontraron eso, sino que no encontraron compuestos orgánicos también. Y eso fue un gran bajón, como decimos nosotros, ¿no es cierto?, que mató al programa de Marte durante mucho tiempo, porque fue una misión tan costosa, ¿no es cierto?, que cuál era el próximo paso, digamos, no había un próximo paso. Así que, en cierto modo, tuve suerte, porque siempre cuento, ¿no es cierto?, que durante esos 20 años que la exploración de Marte estuvo adormecida, yo tuve la oportunidad de terminar el colegio secundario, la universidad, y después ir a la NASA, y después trabajar en Mars Pathfinder, que fue la siguiente misión que aterrizó en Marte.
¿Cómo fue ese renacer o la siguiente ola de esas misiones, o sea, donde vos ya participaste de manera mucho más activa?
Bueno, fue medio extraño, porque Mars Pathfinder era una misión con un costo muy bajo, parte de Faster, Better and Cheaper, que era una nueva filosofía. Dan Golden era
el bueno, bonito, barato, digamos.
Claro, exacto. El costo de las misiones era muy alto, y entonces el director de la NASA pensaba, bueno, por el costo de una misión, ¿no es cierto?, de $1.000 millones, podemos hacer 5, y si nos funcionan, no todas, pero la mayoría, salimos ganando, ¿no es cierto? Esa era la filosofía, y Mars Pathfinder fue una de las primeras. Pero cuando me llama mi jefe y me dice, mira, ¿querés trabajar en una misión a Marte para que aterrice el Marte? Está buenísimo. Dice, sí, pero las probabilidades de éxito son muy bajas, ¿no?, porque vas a tener bolsas de aire, así que no era más mecánica la cosa que ingeniería de guiado de navegación y control.
Era más fuerza bruta, digamos.
Era más fuerza bruta, pero igual yo salté a la oportunidad y me cambió la vida, porque realmente no solamente fue, digamos, la misión que me hizo, que pude decir, ¿no es cierto?, logré lo que vine a hacer, ¿no?, que era trabajar en una misión que aterrizaba en Marte, pero también, digamos, me divertí mucho haciéndolo, porque siendo una misión muy pequeña, había más oportunidad para cada uno de los ingenieros e ingenieras hacer más, ¿no es cierto?, que era algo que a mí me gustaba. Cassini era una misión enorme, ¿no es cierto?, pero muy compartimentalizada. Si vos hacías el algoritmo matemático, lo probabas en MATLAB, escribías un libro así grandote, la receta, ¿no es cierto?, se lo dabas a los ingenieros de software, que escribían el software, después se lo daban a los ingenieros de testeo, ¿no es cierto?, así, ¿no es cierto?
Proceso en cascada, digamos.
Sí, tipo Henry Ford, ¿viste? Como, y eso me resultaba muy frustrante para mí, porque quería poder seguir, ¿no es cierto?, el proceso. Y Pathfinder era así, es decir, me dijeron, mira, estamos buscando ingenieros cradle to grave, decía, ¿no?, desde la cuna hasta el ataúd, no sé cómo se dice, y cosa de que se queden todo el proceso, y de esa forma eliminar también mucho documentación y burocracia, la cual odio también, viniendo de Argentina también. Es decir, uno odia la burocracia, y bueno, entonces podíamos realmente explayarnos y tener muchos roles en muchas áreas, y fue muy, muy divertido. Y dije, esto es lo que yo pude decir también, esto es tan divertido como yo me lo imaginaba, ¿no?, porque uno tiene que disfrutar lo que uno hace.
Claro, sí. Y después hubo misiones que se fueron sofisticando, ¿no? Digamos, Curiosity y eventualmente, digamos, Perseverancia, digamos, que ya no son misiones baratas y tenían mecanismos mucho más sofisticados. ¿Cómo fue dándose esa curva, digamos, de complejidad y aprendizaje por parte del equipo hasta llegar, por ejemplo, a la de 2020?
Bueno, en primer lugar, yo creo, ¿no?, es que el hecho de que fuera ese grupo de Pathfinder, creó un cierto grupo que no solamente de personas que no solamente trabajábamos muy bien como ingenieros, pero también había un lazo de amistad que nos permitía confiarnos unos a los otros, y yo creo que fue fundamental eso. Después ese mismo grupo fue moviéndose a otras misiones y fue creciendo, pero siempre había una especie de masa crítica que nos permitía a medida que los nuevos ingenieros e ingenieras se acoplaban al proyecto o los nuevos proyectos, nosotros podíamos pasar esa forma de hacer las cosas, digamos, ¿no? Porque hay una cierta arquitectura, una forma de pensar. Así que, en cierto modo, esos proyectos, Spirit y Opportunity, después Curiosity, hay mucho de Pathfinder ahí, ¿no es cierto? Lo tenés que ir a buscar, pero está, ¿no es cierto? Es muy difícil, entre paréntesis, de codificar qué es el método Mars Pathfinder de hacer las cosas, pero lo hay, lo existe, pero a veces yo siempre digo que a veces es más difícil explicar el éxito que el fracaso, por el fracaso explicás la cosa que se rompió, pero cuando las cosas funcionan, ¿qué es lo que hicimos bien? Algo hicimos bien, pero no sabemos exactamente qué. O todo, pero es muy sutil a veces las dinámicas de equipo que resultaron ser tan útiles, ¿no es cierto?
Y se nota que es un equipo muy unido y vos la última vez, en 2020, te tocó vivir ese aterrizaje en Marte, digo,
Sí.
amartizaje se dice a veces, pero bueno, no me gusta mucho esa palabra, desde tu casa, por la pandemia, y hubo un video que vamos a ver si lo podemos ver, que te hizo un tanto más famoso de lo que ya eras. A ver si podemos pasar.
Para que no funcione.
Touchdown. We got touchdown.
Nominal.
Bring me a stable.
Bring me a stable.
Bring.
Don't break the table.
Tenía acceso a toda la telemetría, así que muy nerd, muy nerd.
Tres cosas de este video. Uno es que creo que lo viralizó tu hija, que está conectada,
Sí.
está conectada siguiéndote.
Tiene que
así
pagarte.
La segunda es que, para los que no lo saben, es un video que realmente muchísimas de las agencias de noticias de Estados Unidos te buscaron, ¿no? O sea, me parece que tuvo una repercusión enorme.
Tuvo una repercusión muy grande. Y bueno.
Y la tercera es que me llama la atención que en pandemia estábamos todos trabajando en nuestras casas y vos estabas manejando robots en Marte desde tu casa.
En realidad yo era un espectador en esa altura, es decir, fui consultor en esa misión, por eso que estaba ahí, porque no tenía ningún rol el día del aterrizaje, pero mis amigos me ayudaron a conectarme con todos la telemetría y el audio, así que yo podía vivir el aterrizaje como haber estado en el centro de control, así que estuvo muy divertido.
Sí, no, la verdad que fue increíble, es algo que me llamó mucho la atención de ese periodo, más allá de todas las cosas que pasaron, como ciertas misiones que la ventana de alineación planetaria no te va a esperar.
Sí, había que hacerlo.
Había que hacerlo sí o sí. ¿Qué es lo que se viene? O sea, porque uno puede mirar siempre para atrás y podemos quedarnos charlando toda la tarde y probablemente los otros invitados nos van a echar. Sí. Pero ¿qué se viene y qué es lo que más te entusiasma?
Bueno, se viene un montón de cosas. Estamos viviendo un renacimiento de la exploración espacial y es a nivel mundial. Ahora ya no solamente de los Estados Unidos y Rusia, ahora tenemos India, ¿no es cierto?, que acaba de aterrizar en la Luna, y tenemos China aterrizó en Marte, así que es muy interesante. Tenemos un sector privado pero muy dinámico. Ahora tenemos un montón de misiones que vos sabés, ¿no es cierto?, que son misiones de compañías, es decir, con esta nueva usanza que la NASA utiliza con la industria privada, que va a mandar muchas misiones a la Luna, robóticas, ¿no es cierto?, que va a estar muy interesante. Espero que funcionen. Pero de ser así se inaugura una nueva, forma de hacer las cosas, ¿no es cierto?, que se extienden, digamos, de la órbita terrestre ahora a la parte lunar, y en particular el trabajo que estamos haciendo en el JPL, ir a buscar las muestras de perseverancia y traerlas a la Tierra es el próximo paso, y para mí, en lo personal, probablemente sea la parte final de mi carrera.
Qué manera de cerrar, ¿no? Porque sería la primera vez, si no me equivoco, que muestras de otro planeta, no hablamos de la Luna, sino de otro planeta, se recuperen
Sería, exactamente, y no es fácil, es bastante difícil y caro, ese es el problema.
Y sé que los que trabajan en misiones espaciales odian esta pregunta, pero ¿cuándo estarían esas muestras? O sea, ¿cuándo se planifica que...?
Y no más temprano que el 2033, calculo yo, 34, ya perdí la cuenta, pero va a llevar muchos años.
Se planifica siempre a largo plazo, ¿no?
Absolutamente. Hay que tener paciencia en este mundo.
Mencionaste a los nuevos actores, mencionaste a India, China, bueno, el sector privado que si bien siempre participó, tiene otro tipo de relevancia.
Es otra modalidad de participación que está dando muy buenos resultados.
¿Cómo se da esa dinámica, por ejemplo, trabajando con empresas como SpaceX o demás, en donde ustedes tienen su forma de hacer las cosas, que puede estar bien o puede estar mal, pero vienen haciéndola de una cierta manera, y las empresas privadas quizás tienen otra forma de hacer las cosas? ¿En dónde se da ese punto de contacto? ¿Qué tipo de compromisos se tienen que dar?
Bueno, en primer lugar, hay dos formas de interactuar con las compañías privadas. Por ejemplo, en Artemis, que yo estuve un poco involucrado en eso durante un tiempo, en HLS, Human Landing
El
System.
sistema de aterrizaje para los astronautas.
Exacto, el módulo lunar sería, ¿no? Hay una que es, digamos, de supervisión, que le llaman Insight, no le llaman supervisión, y donde la NASA supervisa lo que están haciendo, pero le dicen soft touch, es decir, le pueden decir esto no va a andar, pero no necesariamente decirle cuál la solución es. La idea es justamente insertar la cultura nuestra en ellos, dejar que ellos, digamos, utilicen su ingeniería y su visión y su creatividad. Esa es una forma que la NASA interviene en estas misiones, en estas compañías. Y la otra es, las compañías pueden ir a la NASA y pedir asistencia técnica, en cuyo caso nosotros trabajamos para ellos, ¿no es cierto? Y nuevamente nosotros le pasamos la tecnología, los ayudamos, ¿no es cierto? Para eso estamos. La NASA, aparte, es hacer que nuestras industrias privadas funcionen mejor. Así que le aportamos nuestro conocimiento que ellos nos piden, ¿no es cierto? Y estamos al servicio de ellos. Así que esas son las dos formas que interactuamos.
¿Cómo ves el reflejo de estos nuevos actores que se suman, o no, nuevos entre comillas, porque China viene haciendo cuestiones espaciales hace varias décadas? Vos mencionabas ahí como una que no está tanto Rusia, si bien participa. ¿Cómo se da esa nueva competencia, digamos, entre estos dos grandes rivales, si querés, de esta nueva era espacial, entre Estados Unidos con sus ecosistemas de socios y China por el otro lado?
Bueno, yo te digo, en la parte nuestra, la exploración robótica del espacio científica, la seguimos porque somos, digamos, fans de todo eso, como lo sos vos, ¿no es cierto? Pero en realidad los objetivos nuestros son científicos, nos concentramos en eso, no estamos compitiendo con China o con India, al contrario, incluso un grupo del JPL fue a la India a asesorarlos en la misión de ellos, así que para nosotros la misión nuestra es el conocimiento científico y tratar de buscar los secretos de la ciencia es lo que nos desvela de noche, digamos, no lo que están haciendo los chinos o la India.
Y por último, ¿qué consejo, me retomo la pregunta que le hicieron antes a Megan, qué consejo le darías a las nuevas generaciones que están de vuelta, quizás interesadas, quizás vieron algo en el planetario, pero no saben cuál sería el siguiente paso para decir, yo también quiero trabajar en el sector espacial, yo también quiero hacer naves que vayan a Marte?
Bueno, como Megan dijo, la pasión es lo principal, ¿no es cierto? Y yo siempre digo, está bueno tener un objetivo final, ¿no es cierto? El mío era trabajar en unas misiones espaciales que aterricen en Marte, pero lo importante es que en todo paso, digamos, de ese viaje, ¿no? Ese journey, que lo disfrutes. Digamos que no, si el camino es muy arduo y no lo estás disfrutando y elegiste el destino incorrecto, ¿no es cierto? Tiene que ser algo que vos día a día te despiertes a la mañana y estés contento de que vas a ir a trabajar en eso, que vas a estudiar tal cosa, ¿no es cierto? Es decir, que tiene que haber un objetivo que es el hoy, ¿no es cierto? Que es estudiar ese nuevo capítulo, esa nueva técnica, y te tiene que dar placer hacerlo hoy. No podés esperar que todo el placer sea 10 años cuando llegues a la meta, porque si es así, no elegiste la meta correcta.
Bueno, Miguel, muchísimas gracias.
Gracias a vos, gracias.
Muchas gracias. Un aplauso para ustedes. Los hice aplaudir de nuevo. Che, qué bueno. De repente escuchar esta charla es como, esto existe, es real, no es ciencia ficción. Un poroto la ciencia ficción al lado de lo que sucede. Y qué lindo viaje es meterse en la página de la NASA a bucear por todo lo que sucede en ese mundo. Es de repente mejor que Netflix. Bueno, nos queda una conversación más. ¿Cómo la están pasando? ¿Bien? ¿Están cómodos? Esos sillones son lo más, ¿no? Como que de repente es reconfortante. Los videojuegos en general tienen mala prensa, ¿no? Como, ¿qué haces? ¿Jugás a los jueguitos? Pero la conversación que va a suceder a continuación es muy interesante. La va a dar Juan Cruz Nares. Él es programador, pero además es deportista de alto rendimiento y hace snowboard. Esta noche se va a Ushuaia. Es un genio. Y va a conversar con Douglas Crockford. ¿Por qué digo esto de los videojuegos? Porque en su recorrido Crockford empezó programando videojuegos y eso lo llevó después a programar y ser un experto en JavaScript o de repente, nada, ya, ahora lo van a conocer porque me parece que no, él va a hablar por sí solo, pero gracias por estar acá. Hasta el sábado. Los vemos en Nerdearla en el Conex. Chicos.
Hey everyone. I'll ask you a bit of patience with me. I speak moving my hands, so if I suddenly stop hearing me, please be patient. I'm not very used to using microphones. Hey Douglas, thank you. Thank you for coming, for being here.
It's very nice to meet you, JC.
Thank you. I want to start talking. I watched your talk today at Nerdearla, and quite a few times you had to say, like, I don't really care about what other people are doing after certain questions. And so I'm going to start talking about you, and especially you have...
May I respond to that?
Yeah, sure.
So earlier in my career, I was a technologist.
Yeah.
So it was my business to be aware of what everybody was doing. So I was reading all the periodicals, all the journals, I was going to the shows, we didn't have internet yet, so it was a little harder to find stuff. But I spent a lot of time searching and trying to figure out what other people were doing and what the trends were. And particularly when I was at Lucasfilm, my job was to try to find the new emerging technology for entertainment and determine if it's going to be fun enough. So I've done that side of it. But now I'm at the stage where I don't care.
Okay, good. That's a nice stage.
I can focus entirely on what I'm doing, what I think is important, and I don't need to put it in the context of what anyone else is doing.
Okay, that's a nice place to be. So, going back, like for example, you had a very colorful career. So you started, your degree is on radio and television, that's right, that's
right.
correct.
Mm-hmm.
So, and then you started by doing video games for Atari? That's,
there was a lot before then. So I went to San Francisco State University, and I majored in radio and television. My plan was to grow up to be a television writer.
Okay. And from that, you became the JavaScript guy. So
Yeah.
That's quite the leap.
Yeah, it wasn't a straight line.
Yeah.
So television was the most expensive major at the college because they had 3 TV studios and several radio studios and a team of engineers to keep it all running. It was really expensive.
Yeah.
So I could not get into the studio in my first year.
Oh. So what did you do?
So I went to the math department and took a class in Fortran.
Oh, that explains a lot of things. So, Fortran, it's a very unique language in a sense.
Well, from today's perspective, we'd say it is primitive.
Yeah, it was advanced at the time.
It was very
it was
advanced
revolutionary.
at the time. It was revolutionary. It was one of the big paradigm shifts, for sure.
I agree with that. And how you got into languages in particular, because there's a trend, like even before JavaScript, you started electric
communities. Yeah.
And you had the E programming language around 97 or something like that, which introduced quite a few interesting concepts like the promises and today, I don't know, people that do JavaScript today would recognize like React as a framework. Many of the fundamental concepts that they use, in a way, they were in the E programming language, but more intrinsically built into that. How did you get into that?
Right. So we wanted to build a company that would build an infrastructure to support community and commerce.
Community what?
Community and commerce.
And commerce, okay.
So that people could get together online and play together, communicate together, socialize, and also to buy and sell things from each other.
Okay, cool.
And to do that all securely. And
in
to do it,
97, so.
yeah, and to do it in a way which was fully distributed, so that there was no single company, not even us, in the middle of it, that people could do that stuff themselves. So building a fully secure global distributed network was a challenge.
Yeah.
And
It still is.
It still is. Yeah, nobody's done that yet.
Yeah, I don't think we are there yet. We have a hodgepodge of things that work, but we're still fully there.
Yeah, unfortunately, everything has become re-centralized, right? And there are a small number of very large companies.
Yeah, economically re-centralized. I think we are in a weird place. Maybe technologically, I'm not so sure, but from a financial perspective, yeah, that's true. That's definitely true.
Yeah, so we had to develop our own tools in order to accomplish our goals, and one of them was to develop our own programming language. And I was funding the development of a research language at another company, and that company's management kind of went nuts, and we couldn't get a license to use the product that we'd been funding.
Oh, okay.
So we were suddenly in a panic, how do we go forward? So we decided what we should do is find another existing language and add the security features that we required and the communication features that we required on top of that. And the 2 languages we considered were Smalltalk and Java.
Okay.
And I made the wrong decision.
Okay. You would have gone with Smalltalk.
We should have gone with
Java.
Smalltalk, but we went
Yeah.
with Java. And that was a problem because Sun did not want us fixing their language. And so they were very hostile to us.
Sun was hostile at the moment. Yeah, but they were a weird company at the time.
Well, they were promising that it was going to be an open source language.
And they never fully committed.
Well, when it looked like it was going to make money for them, they kind of, well, there's open and there's open. And
okay, I get what you.
So anyway, we took Java and we turned it into the E language. And we made 2 versions of it, and they're both really interesting languages.
Yeah.
And the second one had promises in it, and those promises found their way.
I saw that one. I missed the first one.
Yeah. So the promises found their way into Python first, I think, and eventually into JavaScript.
Even Java, they call them futures, but they're...
Well, futures is a much older idea, but...
Yeah. Okay.
But all that stuff is great. Unfortunately, by the time Promises made it into JavaScript, they'd completely ruined it. So that's a disappointment.
In which way would you say they ruined it?
Well, Promises were originally intended to support secure distributed programming.
Yeah.
So that you could send something to another machine, and it had a pipelining feature in that you could send messages to that future object that would be the result of your request on that machine, and the messages would get delivered before that object is instantiated.
Okay, I get it.
And so by doing that, we were going to make things a lot faster. But what it's being used for in JavaScript is to manage concurrency,
Yeah.
which it does, but it does it really badly.
That's probably influenced from the browser itself, because the rendering model of
Well, no, that's one of the few things the browser got right. That model, the single-threaded thing, event-driven, yeah, that's brilliant. Yeah, Netscape accidentally got that part right.
Okay, that's interesting. Because the other one thing when I think of JavaScript, at least the early versions, the newer versions I haven't followed in that detail, but the Netscape 2 versions, it felt a bit like when IE6 was good, essentially that time, when, because believe it or not, IE6 was good at a certain, was the best browser available at some point.
Although that came quite a bit later.
Quite a bit later, yeah. But I'm thinking like the feeling that you get, like, for example, variable hoisting or everything global, the bad parts, if you like, of JavaScript. They feel, to me, coming from a compiler background, it's like, yeah, we'll leave scope and the symbol table for later and just leave a simple hash map there and drop everything on the global context, and then somebody said, release this, and out it went, and we're stuck with that forever. To the point that eventually we ended up adding LED and stuff like that to try to patch the system. Do you agree in that?
Yeah.
In that, that it feels like half-baked in a sense?
Oh, absolutely. The first time I encountered JavaScript, I thought it was the stupidest thing I ever saw.
But you found the good parts.
Well, then I ignored it for 10 years.
Okay.
And then circumstances required me to take a second look at it. And I noticed that there was something truly brilliant in the language that they didn't tell anybody about. I think the designer of the language kind of snuck it in.
It was a sleeper, wasn't it? Because they picked the name of the popular technology at the time, JavaScript. Nothing to do with Java at all.
Totally confusing, yeah.
But they did it right. They played it right.
They did that. Netscape and Sun had an alliance for a while, and it was a complicated alliance.
Okay.
And so each was trying to do things independently to get over the other, and both resented the thing.
Underhanded kind of.
Yeah, it was complicated. So Netscape created a language that they called LiveScript for a while.
Okay, yeah.
And they made an interconnection in the browser called LiveConnect, which allowed LiveScript to talk to Java applets. And they did that really fast and dirty, and that was the only interface that they had for Java to interact with the browser. Sun was really annoyed at that, because they were saying that Java is the only language you ever need from now on.
Just put the applet there and replace the page. It was basically
the idea. What are you doing putting this other stupid language in there? You got to take it out. But Netscape couldn't take it out because then Java wouldn't work, and so they couldn't fulfill their agreement. So as a compromise, they changed the name to JavaScript and told people that it was not a different language, it was a subset of Java. It was interpreted Java, so don't be upset.
So they basically snuck a functional programming with prototypes and called it Java, which was kind of funny, but...
Yeah, and for a decade, we had people really confused about what the difference was.
When I think about Sun, it's like, at that time, they used to have this phrase like, besides the run anywhere, it was like the network is a computer, and they were so right in such a wrong way about that. Because if you look at that from now, knowing what we know today with the cloud and the way that services and the way you deploy things and build modern distributed systems, even though there's still a hodgepodge of stuff, they were right. The network has become the computer in a way. Most things do have the compute somewhere else. But they couldn't quite, they had the right idea, but they failed in the last mile. And I think that happens a lot with technology. Sometimes you have something revolutionary that at some point is kind of off, but eventually right.
Well, you have to understand when you're in the middle of this stuff, you're trying to invent a new market and nobody, you're not to the point yet where it's obvious how it's going to turn out.
Yeah.
And so,
yeah. In hindsight, it's 2020.
Yeah, in hindsight, you say, well, why'd they do that? That was stupid. But at the time, it looked like the best move available.
I remember the Java stations or stuff like that. They had quite a few things. And then I think it was Ajax, basically, that made JavaScript the thing in a way, because it started allowing building applications, what we eventually got called Web 2.0 or something like that, when you essentially build the application and runs mostly on the browser with a backend.
Right, so the lead up to that was in 2000, Forrester Research published a set of articles where they said that the current web is inadequate because it's just a document retrieval system. That's not what the future needs. What we need is an application delivery system. So they were talking about the web being replaced by a better system that they called the X-Internet, the executable internet.
Mm-hmm.
And they predicted that it would replace the web the same way that the web replaced FTP and all the earlier protocols. All those.
Gopher.
Yeah, exactly. All the Gopher protocols, all the Mosaic protocols that they were all obsolete. And the web was going to join that set, and we're going to go to the X-Internet. And they predicted that would happen by 2002.
Okay.
The reason it didn't happen was that the browser was already the X-Internet because JavaScript was in it. It was just that nobody had recognized it yet.
Yeah, thankfully ActiveX didn't pan out, which was another.
Yeah, so if JavaScript had not been in the browser, we would not be talking about the World Wide Web anymore.
I think it was transformational in a sense, that in a deeper sense that I don't think anyone foresaw. Even, for example, your other contribution, Jason, which is basically, I think it's a fantastic intersection of encodings, if you like. So it's really simple. It has what everyone supports rather than what everyone would want.
Yeah,
and that's enough.
Right. So Jason was not the first attempt to make a data interchange language. That there were.
Well, we had XML,
which was awful. It wasn't even a data language. It was a document format.
They flew from SGML and ran with it all the wrong ways.
Yeah, that was wrong. There were earlier examples which tried to solve the union problem, where they, all these different languages have all these different interpretations of what a number is and a string is and so on. So let's come up with a format which can express all of those differences, and then you've got specification languages for dictating which versions of everything you're passing around. Jason took the opposite approach. It tried to solve the intersection program. What is common to every programming language? And that thing is every language has numbers. We all disagree on what a number is, how many bits it is, or whether it's binary or decimal or whatever. But we can agree that you can take a string of digits, and we'll all agree that that's a number.
Yeah.
Done. That's what JSON does.
Yeah.
And as a result, it's just really simple, and any two programming languages can exchange data in it. It's really straightforward.
It was adopted fairly quick, and it ran like wildfire, so you would say, like JSON took over the world. And this makes me think a bit about adoption in general. So what do you think are the main, even if it's a data format or maybe a programming language, what are the main factors in your mind that influence adoption, besides luck? Because luck, it's a factor of.
You can't underestimate luck.
Yeah,
Luck is a huge factor.
You have to be at the right place at the right time to be able to, but still.
Right, so I've experienced many of the paradigm shifts in the evolution of programming languages. I remember talking to old machine programmers who would not bother with Fortran because it took too much control away from them, even though assembly language is infinitely harder than Fortran. And there were similar arguments that we can't move away from Fortran.
The hammer argument, basically. All I have is a hammer, everything is a nail.
Yeah, so for most people, they get imprinted by their first programming experience. Whatever that first language was, probably something they learned at school or in their first job. That's what they're stuck with. In addition to being educated, they're also brain damaged. And they see any form of innovation as a threat, and it makes them uncomfortable.
Well, we are still dealing with Go as a reserved word and waiting for the extra to be wrong.
Yeah, exactly. Java was not confident enough to take the keyword out.
The keyword away.
Yeah. Which is, it should have been obvious by then that we weren't going to use GoTo anymore.
Yeah, we were never going back.
Although there were recommendations to put GoTo back into JavaScript. And I was really not happy about that.
Yeah, well, probably the WebAssembly guys. I would think that they would want something like that.
Well, the justification was that JavaScript was becoming a compilation target.
Yeah, the WebAssembly guys.
Yeah, exactly. And so they wanted a way of being able to write more optimal code and not having to do tricky loop escapes in order to get to places. But the thing is, if they had put GoTo in, a whole new generation of idiot programmers were going to start using GoTo because someone told them it was faster.
Yeah.
And
finding an excuse of why it's good.
Yeah. So one of the big factors in adoption of a new language is we have to wait for a generation of programmers to retire or die
so a new one
before we can advance to the next one. I've seen this happen over and over again.
Okay, makes sense.
So we like to think we're looking for innovation. When the new idea comes, we all recognize it immediately.
We don't want innovation. We're very, as an industry, we're still doing the things that we know it works. So we like a little bit of patina, but radical innovation, it's usually frowned upon. Yeah.
So in 1980, Smalltalk 80 comes on the market.
Mm-hmm.
It is the best designed programming language in the history of the world up till that point. And
yeah, I think it's
C++
a religion.
comes out of Bell Labs.
Bear with me, but I think more than a programming language, it's a religion today. People that love it blindly.
Yeah, well, that's another problem.
Yeah.
So we had this beautiful, elegant, everything's an object-oriented language, and we had something which took C, which was already a problematic language. There were deep defects that were intentionally put into C because it had to run in 16K.
Yeah, they couldn't compile it, so they had to add something so it would fit.
Yeah, so they didn't do garbage collection, they didn't do safe pointers, they didn't do strings right. There were a lot of intentional mistakes because they just didn't have enough memory. But then the language, or the machines got big. So now we have machines with megabytes of memory, and we still have this crippled, sad little programming language. C++ took that and added objects to it, which makes no sense.
Yeah, I think of C++ more like, rather than a programming language, I'm not sure it's a programming language. For me, it's more like a scripting language for the compiler. So it's essentially, you're basically, the compiler is the one that runs the program and generates something from it.
Right, so we had two languages, one which was beautiful and elegant, perfection, as close as perfection as any design had ever seen. And we had this thing that looked kind of familiar.
Yeah.
For this one, it's all object, so you have to fully embrace object-oriented programming or you can't get started. In this one, you can ignore it. You can still write in Fortran style if you want, and it'll compile and run.
Yeah,
That's the language we picked.
I think, going that, if you think of if what you came from was C, so I would see the inertia there. So because you could take C++ and compile C code, so that's a huge selling point for people that essentially are
who don't want to learn the new paradigm.
You don't want to, yeah, essentially you don't want to throw away and start. You want somebody that's paying somebody is going to ask you, no, just use whatever you built. And
right, so the cost of the new paradigm is always you have to learn to think in that new paradigm. Yeah. And sometimes it's a little thing like just learn to program without go-tos. And that was impossible, right? Go-to, you know.
Without global variables. Global variables were the hard thing to let go, if you think about it. It's not something that global state in earlier programs was a lot more common, I think, especially coming from structured programming.
There was a standard recommendation for Node to put global variables back in it.
Oh, okay.
So this stuff is hard. People don't like to change. They don't want to adopt the new way of thinking. But that's the only way we make progress.
Okay, Douglas, I think we have run out of time. But thank you very much for joining us, for being here, for giving the talk. Thank you.
Thank you.
Muchas gracias. Full nerd esta conversación. Aguante conocer la historia de los lenguajes de programación y las picas que hay entre programadores de acuerdo a su uso. Mañana vamos a seguir en Nerdearla, el sábado también. Estamos en el Conex. Vengan, por favor, que va a estar buenísimo. Este es el fin de la jornada desde acá del Planetario. Ojalá volvamos porque es hermoso este lugar. Mi nombre es Gala, pueden seguirme como Chip Tecno ahí en las redes. Y gracias por la paciencia y por estar acá. Gracias a ustedes. Chao.